Let's dive into the topic. Right, today's topic, you can talk about the .NET 8. .NET 8 released on November 14th, which is the LTS release, which is called the long-time support, which means that they support for 36 months. Short-term support is for 18 months, right? Before we continue the topic, a little bit about me. I'm Udaiappa Ramachandran, shortly call me Udai. I work for a company called Akimina. I also have an MEP award, been in the space for a long time, using Microsoft Azure, AWS, and Google. I run this user group along with the Dan. So that's the URL. You are all here, and that's my little personal page. I just updated what I've been doing for the community. Here is the agenda. .NET 8 is a pretty big release in terms of performance and functionality, part of .NET 8 C# 12. There's hundreds and thousands of features. There are hundreds of performance improvements. But I only handpicked or called cherry-picked the thing that we use in our daily life, daily programming. So you are here, I would assume that you are also a .NET developer. So I cherry-picked the one that I use in my real projects, and I also going to assume that this will be most useful features to talk about it. If you haven't installed, and you can download and install from this link, .NET 8, it comes with Visual Studio. If you install Visual Studio 17.8, it comes with that. So it's obviously you can install it over here. Now let's go one feature at a time. So the first thing we can talk about is the search values, right? If you look for some string we all do this contains, right? It's a contains or index of. If you take any applications, there are several times you can look for index of this is greater than 0 or contains so and so pattern, right? So pattern matching. We all use that. But now they have something called search values, which creates the efficient way of looking for a string inside it. That's what you can talk about. It's a fast way of searching it as per the site and then the information that I gone through. And ASP.NET libraries, or ASP.NET libraries, internally they use these new search values to look for it. I don't think we have any code without index of contains. If I run through my code, I see like hundreds of places index of contains, or you name it, right? So the pattern searching. So that's the first thing we're going to see it. Second thing we're going to talk about the dynamic PGO means that profile guided optimization. What does that mean? If you have a loop that you iterate through, right? So you have something you do like 100 times, 1,000 times, maybe 100,000 times or 1,000,000 times. You do over and over and over. The system learns what you are trying to do. The compiler learns the runtime learns what you are trying to do, and it does the tier they call it as a tier 0 compilation. That's the first one, and after that, based on how you are running, it recompiles your code on the fly, and then switching to the tier 1 compilation. That's going to be more efficient on a memory and size and the faster execution. So that is called the profile guided optimization. So it takes your code. This is mainly useful if you have the iteration over and over and over, and there is a lot of memory allocation involved. And this is it switches the tier from 0 to 1. It changes that execution flow differently, and to optimize this memory and faster for the better performance. That's the second demo we're going to see it. Third one is the JSON unmapped member handling. So what does that mean? So if you have the JSON object, right, properly X and Y, two attributes, if you're trying to deserialize, it's not going to throw error, the plain POCO, right? So your JSON property not necessary to map with the object you're trying to deserialize. You can pass it in any, but we don't throw error, but you may get a null, or you may get no property set, right? But it will not throw error. But now you can force that by setting the disallow, right? Meaning that if you have the, X and Y is your POCO, contains a property called X and Y. If you don't pass X and Y, it's going to throw error. Or if you pass X and Z, where the X and Y is the properties, it's going to throw error. So that's the third one we're going to see. The fourth one is a time abstraction. This is mainly helpful if you have done an application that needs the user from multiple different geographical regions, right? We are from Houston, US East. Most likely you are, people from different regions, Central, Middle, Pacific, or maybe another country, Europe and India, you name it, right? When the user can come from there, the server also runs from everywhere, right? So when you want to control that global language, global timing, it was, we have to do some manual conversion by using the datetime object, trying to add, minus, and on top of that, the complexity involved and the daylight savings, right? Every year there is a daylight saving. Some countries the daylight savings are different. Other countries they don't even do the daylight savings. So this gives you an opportunity for you to control how those timing can be handled. We'll see that how it's been done, and then the compression. If you are doing compression, zip and unzip, so now the compression does not use the folder. So you have a large file, a large folder structure, which takes, say, for example, 1 gig, right? So it needs intermediate folder to do all the operations. Now it does not need an intermediate folder, but it can do everything in the memory, and hence you are not going to run out of space or something. I believe some applications will use trying to create this kind of dynamic zip files or unzip based on what type of application you build, but I believe that's another feature that we're going to see today. The last one is the, not last one, the next one is the regular expression source generation. If we saw the string value, right? The string value is going to use some pattern, right? You're looking for ABC, 1, 2, 3, or anything you may be looking for. Now you can see, instead of reflection and trying to do that, you can see the compile time, it emits the code, and hence, it creates all the syntax, all the regular expression on the compile time instead of the runtime, right? Instead of translating the runtime, it creates everything on the compile time. So your source code is emitted, is compiled a part of it. So that gives the performance because there is no reflection involved later stage. So it is the code is generated, in compile time. There's another one called FrozenSet. We can solve this problem by using the read-only collection, but the problem of FrozenSet and read-only collection is FrozenSet, it's a one-time penalty to create the FrozenSet, and after that you can enumerate in a much faster way as per Microsoft. But the read-only collection, you can solve the same thing in the read-only collection, but it is not a thread safe, meaning that you are creating a dictionary or list or whatever collection or whatever name it, you convert to a read-only, then you can still mutate the base objects, right? So you can go and modify it. So it's not thread safe. But the frozen sets, once you create it, you cannot modify it. You can just use it for the enumeration purpose. And then there is a performance on the add range functionality, and then int32.2 string has some performance if you've been using integer.2 string in your code a lot of times. Cryptography, there is a SHA-3 implemented out of the box, and there is a get items where you can use it part of the cryptography to pick random items from the list of collections. The next one is the system.text.json, which can, if you do deserialize and serialize, right, back and forth, what it does is the reflection, right? So instead of doing that reflection, now they emit the code at the time of compilation, and hence is a better performance. There is no transforming that object into another object and doing everything in the in-memory. That reflection is completely gone. They can do that, but there is some parameter you can turn on and off. We will see that in a demo. All right. So let's take a break there. Let's run code and then walk through from there. So whatever I gone through that slide, I commented all the code here. So let's run one at a time. The first thing what you're going to see is the search values demo, right? So I'm going to comment this code here. So let's see the primary constructor. What is a primary constructor? Okay, the primary constructor is, if you take, there is an example over here. public. Okay, so this is the primary constructor, right? If this is not here, you usually create the public and class name test time, right? So we usually create something like this, right? Public time test, and then we're going to say time provider, right? That's a provider, and then you assign to a provider, right? So you define a variable and then assign to it. So if I remove this over here, it's going to tell me you can use the primary constructor. So I just say time provider, and then I say provider is equal to provider. Right. So now, this is how we used to do, but this can go as a primary constructor like that. So that's the easy syntax. Okay. So that's the primary constructor. Then it says, based on how many the default constructor arguments, you have 3 or 4 or 5, then the number of lines it's saved, the compiler will take care of how to handle the primary constructors. That's called a primary constructor. The second one we're going to see is the search values. I'm going to uncomment this function over here, right? So I have some class called search values demo. You look at this, and I'm looking for some string. This is a small string. You're not going to see a huge difference, but you will see this huge difference. Say, for example, you're trying to validate you have a base 64 string or not, right? That is a best example. The base 64 string, it can contain the combination of A to B, A to Z small, A to Z upper, plus equal sign, right? And then the forward sign, I guess. So those signs. So if you want to create that today, if you want to write your own mechanism, you have to say A, B, C, and so on, Z, and then start from capital A, B, and so on, Z, then 0 to 9, and then you say plus, forward slash, and then the equal sign, right? So that contains like a 26 plus 26 plus 10 plus 3, 52, 62, 65 characters you need to list it. But now you can do that just by saying A, B, C, just list that value. You don't have to split them in a char array and do that. So this is the legacy way of you doing this stuff. And this is also called the primary constructor because you don't have to give the type, but it knows based on the declaration that is going to be the, new of the character array. This is also a primary constructor. So now, that's the legacy way you define how you search the, contains this sentence A or B or C, or X or Y or Z, right? But now you can use search values and then define a char array, and then you can create this pattern over here, right? And then you're going to run the iteration of 1 million times. And then you're going to say, this particular thing, if you want to understand, we need to run some benchmark, right? If you're going to run it, you can do, time start, time end, but we will run a little benchmark and see it. This is the test for, say if index of that thing is over there. And then here we're going to look at it, the new pattern. So source.span and then index of those two values here, right? This is a much simpler way than this. This is because we are looking for a small string over here. As I said before, if you want to look for your string is literally, it's a base 64, then you will have to go through that 65 character check is exist or not. So to run this demo, I'm going to enable this benchmark for a second. I'm going to run this benchmark code over here. Okay. In order to run the benchmark, I need to run it in a release mode. It won't run in a debug mode. So I'm going to make that to a release mode. And I'll build this library. Okay. So now I'm going to, once the build is ready. So you may see where all the references are. We put all the loadings from the global usings. And so we don't have to put anything over there. We're directly running it. So let's copy this path. So I'm going to say open the command line, my other window, bring it back. Okay, so I have a command window over here. I'm going to change the path and then cd, and then I'm going to change to this path over here. Yeah, we have the DLL in that path, right? Yeah. So what we're going to do, dot net8 console.exe. Okay, so it tells me, because I'm using the benchmark.net, it tells me I have the one class to be tested. If I have more, you can pick the number. You can pick a star if you want to do anything, but now I can say 0 because that's the number 0 is what I'm going to execute. But in this case, we have only one. It doesn't matter, but if you have more, you can pick the number. So I put a 0, hit enter. It runs the test. We set it to run for 1 million times each iteration. It goes through it. That's the benchmark stuff. We don't need to worry about it. But at the end result, we know what it is. Almost done. So if we look at it over here, test, we're looking for the same exact pattern on both cases. If we go back over here, go to definition, we're looking for A, B, C, X, Y, C, and then the new way, we're looking for same thing, A, B, C, X, Y, C. But this is a very small string. Now, assume this string is too big, how long will it take? If you look at it over here, the second one is the modern way, which is the .NET 8 way, and the old one is the classic way we all used to do. Right? It took standard deviation of 0.05, which is like 5 times, right? And then looking for error, the percentage is more than 5 times. And then the mean is, at least slightly more than 4 times. You see that, it is proving it. If you want to see the memory, you just have to uncomment this and then compile this one, how this is consuming the memory point of view, build, exit it, and then run the test again, 0. This is the parameter while it's running for. So you can also change this parameter to be multiple iterations. For example, I want to run for 1 iteration, 100 iteration, then 1,000 iteration, 1 million iteration. You can keep adding that comma value. The benchmark will interrupt that iteration parameter. It will run like a 1 iteration, then 100, then 1,000, and so on. So you can define as many iterations as you want, part of the parameter value by separating the comma. We would have reduced the values like this lower. Bit done. Complete. Before it ran 9, 37, 44, maybe 50 is 20. Because we set a memory string a little bit more. All right, we'll come back to the let it run. So what are we going to do now? Let's look at it. The next one. So we look at that, right? So we turn the benchmarker, we look at it, how it works, it's running on. The next feature that we're going to see here is the memory limit, right? It's mainly very useful when you're in a Kubernetes application or even a console app, you're in multiple, you want to set the memory limit. And this is the nice and new feature that you can do the memory limit. Right? You can set the max memory you want it and then refresh the memory limit. If you have an application that running, you can programmatically call the refresh memory limit. It will bring down to your memory. In my use cases, we have lots of we have a console app that runs in a multiple threads. Before this, it used to tell us, we have another console app that constantly monitors .NET.exe because that's how the console app runs. And then we get some notifications that apps are consuming more memory. But with this, now we can refresh that memory limit when we need it. If there is a memory consumption more, we can do that. We'll comment that one. Let's see what is going on over here. Okay, so if you look at it, it's got some error. No. If you look at it, so you should look at the memory. Allocated is a 12 bytes for the test, and this one is just 2 bytes, more than 6 times. 6 times is less memory than the old way of finding the index. So that's the that better the search values are performs, right? So this is very simple, and you can call the refresh memory limit. You're good to go. Comment that. I'm going to comment these two. Since we've done this demo, I'm going to comment these two. Let's look at the JSON mapped handler. So if you look at this class over here, so we have the JSON object, which contains ID and department, right? So we're going to deserialize. Deserialize into a user of the JSON. So if you look at the user record, it contains only one property called ID, right? But we are passing it over here, ID and department. If it is not .NET 8 or if it is not decorated by this property, JSON unmapped member handling is disallowed, meaning that if any member come in as mapped, then it's going to throw error. Okay, so if you comment that, it's not going to throw any error. Right, so it's going to assign the ID property and then ignore the department property. Okay, but since we have this feature enabled over here, what it's going to do, it's going to throw error because department is not expected to be part of the user. Right, so we have the exception over here. Let's build it. All right, so let's run the exe. It says that JSON property department could not be mapped to any .NET member contained by type user, right? So, we can run this demo by several combinations, but you understand that. So you cannot pass in the property which is not part of the class, or you cannot pass more property or less property. You just have to map the exact property required by the object. Can be a TTO object, or you name it POCO, plain old object, or the TTO data transformation object, you will call it as. But then if you want to force it, the properties to be in, that's a nice way to force on the latest .NET. Okay, so let's comment this one. The next one we're going to see is the dynamic PGO, profile guided optimization. So if you look at this code over here, we have the dynamic PGO, code to a definition. If you look at it, we run this for how many times? 1 billion times, right? So you're going to enumerate that. So what it's going to do, since it's a repeated loop, it learns from the iterations, and then it's going to change things they call it as the tier 0, tier 1 compilation. Tier 0 is the normal way of going through. Is tier 1 is it learns the system, and then it reprocesses the byte codes, recompiles the code, and then turning that to a much efficient way of handling this. Okay. I tried to demo that, but sometimes my demo is not working. I don't know why, but I will try it now. So we turn on that code, save it. We have in a release mode still. Some of the demo needs things to be in a release mode. That's why I left to run in a release mode. So to run that one, what you're going to do here, we need, in the tech I was walking you through, we need to set some property here. So I'm going to open this. Oh, what is it? Oh, I didn't enter this one. Control C. It again. While it's doing it, I'm going to do that. In command line, you do this. Did copy. I'll set the property that manually. .NET underscore git is some summary. I'm going to set the value 1. Okay. The value 1. Maybe ZX. Yeah. So we compile it. Now we're going to run this exe. Right. So that goes through that. And then I didn't pull the value over here. Give me 1 second here. Let's set this in a different way. Let's set this way. So if you look at it over here, right? So the code was entering. If you look at it, there was size tier 0, the code size 123, IS size 41, and then I don't even understand what's going on over here. But if you look at it, it switched to the tier 1 dynamically. The IS size is not IS size is now 10. The code size is now 10. So this is what they call it as the tier 0 to tier 1 compilation. It learns the pattern and then it changes it to efficient algorithm, regenerates to reduce the memory consumption, and hence it's going to load faster. So that's the evidence. So it was tier 0 and now switched to the tier 1. The next one we're going to see is, I'm going to comment this one. Time abstraction, right? So time abstraction we talked about, it's mainly very helpful when you are building an application that deals with a multiple different users time zone, multiple different computes time zone, and so on, right? So even you put a system or a user lives in a different place, the UTC variation is different. From here, UTC variation is -5 or -4 based on the Eastern Standard Time or daylight savings and so on, right? Every region is different, but this gives you a way to way for us to manage those date time instead of depending on the system date time and then trying to add minus logics to it. So this is a very clean way of managing those things. So I'm going to uncomment this code over here. So if you look at it, you can see this, time provider system get local now and get global now. So time provider is the key. It uses the two things, time abstraction, time provider, system.threading.itimer, right? So this time provider system gives you a local time. There is a lot more methods. This is the new class part of the .NET 8. And how you can do it, so you can, let's look at this class over here, go to definition. So we have a class called time test, and we pass the time provider as a provider, which returns the, we just return random hour, but you can, you can take the concept away that you can provide now, you can control that globalization time, global timing in your own way, in your own code, instead of trying to add minus, where are we right now in standard time or daylight savings. You don't need to worry about it. You can bring it in your own provider to pass in that value. And then you have my time provider, which again inherits the time provider, right? And you can override. If it inherits a time provider, you can override what value you want to give it. So you can say my local time zone is equal to this. So this is how you control. If this code runs everywhere, everything is going to use these time zone values. And then when the time ops, it will return some value. Again, for demo reason, but the main purpose of this is this to helps for us to handle the multiple different time zones and this computes that running everywhere. Wherever we need a time management, daytime, this is most helpful record for us to control it. And we had a long-term problem. Every time the standard time comes in, we need to some patch, classic system. But this is very helpful to control those timings in a code. So if I go and run this code, it's not we'll build it. Control-C. So I need to close this because it still knows the profile guided optimization. So I need to close this and open this again. All right, let me bring this mouse over here. Any question, guys, so far? We have a lot of features we're going to demo, whatever we see in the PowerPoint, so feel free to ask your questions. Dan, you are monitoring, right?
Yeah, absolutely.
Okay. So we now going to run this exe, .NET.exe. .NET8 console.exe. It's a little almost that. Okay, let me remove that value. Set text .NET underscore G from the value. This is some summary. Still brings it Control-C. Because of the memory, I guess. No problem, more time. And a console. .exe. It works out. So, I mean, this is sample. So we're calling the test time test. Just an example, you can pass it in the default provider, which is the static class time provider system, or you can build your own time provider and then pass it in and then ask what you want. You could move on to the next demo. The next demo is the cryptography. I'll just walk you through here. So I don't know how many of you write a cryptography. We do a cryptography for every data that we store. I know Microsoft does that, on at rest to store the data using AES 256. But TLS 1.2 we use to store the data like in motion data. We use the TLS 1.2. That's the standard now. But at rest, Microsoft does the AES 256, and you can do a double encryption on top of that by bringing your own key, right? So we have all these if you do it, but outside of that, you still want to encrypt your data, which you do based on your requirement. In our system, we do some sort of tokens, the user logged in tokens and so on. You can now use the SHA-3, which is the much secure mechanism to encrypt the data. Right. In order to do that, you simply call the SHA-3 create and then just to do it, and encrypt whatever you want. But the point is SHA-3.create. That's the class you use it. The other thing they have here is not a great thing. The random bytes are there already, but what we do is when the user log in, we assign some random bytes. We store the bytes part of the envelope. So we create a random bytes and we attach part of the envelope. We use the random byte to decrypt all the time. So every time you log in, you get a random bytes. But that's nothing new there. The new there is here, get items. You can pass it in the read-only span of the items. It can give you the random items. So if you, in my cases, I may assign multiple tokens to the envelope, and I can randomly look at it. But again, this method is added over there, part of the cryptographic class. Okay, so now let's comment that one. And then the next one we talked about is the compression. The compression is now has the, I told you part of the presentation, you can create the compression without needing an intermediate folder. That saves the folder requirement or size requirement when you want to zip or unzip a large number of files. Mainly on the zip, when you create a zip file, it moves the intermediate folder and then creates that, but now everything done in the memory. So there is no need for the folder. All right, that's very simple syntax. It has several overloads. The create parameter takes a lot of different parameters, so you can look at it. There is lots of overload part of it. Just go through it. But if your application, performs the zip and unzip, that is the great influence. The next one is a frozen collection. We talked about it. You can achieve the same exact functionality by using the iRead-only collection, but the problem with the iRead-only collection is it's not thread safe. The underlying object can be modified, right? It can be a dictionary, collection, or list. You can modify that, but still there is an overhead involved every time you read the data. Okay, but what the FrozenSet has a one-time overload while creating the data, but when you read it, it's much optimized. It's a read optimized collection. And so when you run the code, if you're trying to remove the object on the base object, right? So this is my page base object. So if I go and add to base objects, I remove to the base objects, and I'm going to say 10. Right now, the FrozenSet is not changed, because it is a FrozenSet at the time of the creation. So anything you modify to the base object, it's not going to impact anything to the frozen object. Okay, so if you create some object and you want to pass around to the system for enumerations, and this is the right and better performant way of dealing with that, instead of you trying to create the read-only collection, put them in and passing around. This gives the huge performance. But I don't know what we can demo here, but that that's the FrozenSet. If you want to run it, I can build this one. Let's see. Yeah. So now if I run, I don't have a rerunning, but you got it. So modifying that object. So if I run this object again after here, it's not going to modify it because it's a frozen object. Nobody can modify it. As I said before, you can do the same behavior that you don't need to. Control C. Okay, so it comes under 9, and then we added 10, then again it's only going to display 2 minutes. So let's move on to the next demo. We have a lot of demo to go through today. That's a frozen object. So it can be a dictionary, and anything you name it, you can bring it to the frozen of T of any type, and then you assign that, and then you can enumerate it. It can be a list, collection, dictionary. Next one is this group. So the list one, there is a performance improvements over here, list of T arranged enumerable, which is a new one. And then as per the documentation, there is int32.toString, which anything that you do a toString on the integer, which has the, if you do one time, you don't see any performance. If you do over and over and over, you change the object to toString, then you most likely gain some performance. There may be very minor, not even a microsecond, but it's all about how many users, how many threads coming in, how much of data you're going through is what's going to make a difference. If you're only one person, one thread running, you will not make any difference at all. Okay, so let's go back to here. Here's my slide. Talk about time abstraction, compression, regular expression source, and I'll come back to that. Okay, so let's do the source cell before I switch to a different demo. If you look at it over here, for example, this code line, right? So I go, I look at this code over here. Right, so if I look at this partial class, it's giving me two options, right? One is a partial class, which is the line number 174, which is 171, and the other one gives me the, if you look at it over here, regex generator, right? So if I go open that one, and I modify the class now, I can move to horizontal document group, which is over here. If I go and modify things over there, I want to say something like something, and then it dynamically changes that. Okay. So if you look at it and what it's outputted, it will change to something, and then it will fit for whether it want to use the search values or non-search values. So as you modify, the system generate this code, so it doesn't have to perform on the runtime. Yeah, using the reflection. Now it will create everything over here. It goes through it. It try to create this code, and some point if you keep modifying it, you can see it's using the search values. Okay, so that's code generation on the regular expression. Let's next one over here. All right. So let's move to the .NET 8 core, and those are for C# 12. Normal. You build a business assembly or class, you can use that one. But the .NET 8, there is lots of performance improvements on the Kestrel, how it handles the thread and the network weight and everything. Right? There was a huge improvements from .NET 5 to .NET 6, how the thread weight is happened. For example, the incoming, there is a request coming in, and there is outbound request, right? So how they optimize those wait times is gives the anywhere from 40 to 60% performance boost. But now with the .NET 8, there is a little bit more. So one area is the server improvements on the Kestrel server. That's what the server runs on the Linux and everywhere. Even when you run it locally, you run it, right? And then the header parsing. I don't think there is any web application without parsing the header if it needs to be authorized applications. So, in the application that I work, we have crazy number of headers, value anywhere from, 100 bytes to kilobytes, right? Several, a few kilobytes, maybe 2-3 kilobytes. So header parsing, they have some optimized that crazily, that if your header contains 256 bytes, less than 256 bytes, they're not going through those dictionary, parsing into a dictionary lookup. They have some optimized way of handling in the memory, and hence the memory assignment is completely offloaded. Hence you get the better performance. Okay. If you have more than 256 bytes, they do have to do some memory allocations, but those allocations are optimized to remove the link way of looking at the keys, right? You look at the keys, and then you need to link it, LINQ, and then you look at other keys. You look up the keys over and over. It needs to go through that enumeration. It can, or even the keys.count will take that enumeration, which contains some performance overhead. Those things are fixed in over here. And then HTTP.sys contains a lot more improvements, and mainly that one area they're talking about the buffering. When you write the bytes over the network, mainly for when you download a files, right? If you download a large files from a server that is high latency, so far away server just a high latency. Then now by using the response buffering, you can optimize that how they write over the wire. And as per their documentation, it's like a 70% improvement on the high latency servers. And then kernel mode responsing buffer that comes there, and removed garbage collector handles the response writing, and then the link on the header keys, and then the count. Okay, now let's go and then do some demo over there. All right. So here is, so the one thing that we did not see here, we were talking about the AOT, header ahead of time compilation, AOT, or the caching, right? Caching is there, but in this case, we can talk about the Redis caching that comes part of the object. But ahead of compilation is released part of early versions, right? But that was only available to the console application. So what does that mean is that if you have application, right, you compile it, and the application runs, it needs to transform those compiled code into binary code. At the end of the day, it has to be in a binary code, right? What the AOT does is it removes that stage while compiling. It creates the binary code, okay, and hence everything is smaller, faster, because it removes the need of transforming that compiled code into a binary code, right? So that's happening when the application runs. So you build application, for example, net8 console.exe, that's a compiled code. When you run, it needs to transform that into a byte code. But in AOT, that happens at the time of compilation, and again, is a faster startup and higher performance and lower memory footprint, okay? Which you will see it over here, because the console is already there. It's nothing new, but what they did was they added that functionality into ASP.NET mini APIs only, not on the controller-based API, because there seems to be a pretty big code base, right? But let's explore one at a time here. So first thing, we're going to see the normal web application. So this is some sample data. You create builder, add controllers, there's nothing, right? API Explorer, which comes from this package gen, and then we can add this time provider, okay? In this time provider, if you have a class that's looking for object, something like this, where is it? Something. Okay, so something like this, right? So it can get that time provider to inject it into a constructor as a DI, right? Now, so all right. So this is the normal class. So there is nothing new to normal class. So I'm going to run this class as it is, and then I'm going to we will explore all the features. So that's the one thing, time provider system, which we already looked at it, but now you can pass around. If you have the your constructor is looking for this, and it will be injected, right? The second thing that I want to highlight over here is the keyed singleton, right? So before, if you have an interface, in this context, you have the interface called my_time, and we have two implementation, my local time, my UTC time, right? Before, what you can do, you can enumerate it and then look at it, right? So there is no way to call by the key name, okay? But now you can inject this as a key name. So that's called by the add keyed singleton. There is a multiple over, if you want a singleton or non-singleton, you can go through it, add keyed, scoped or transient. If you want to use it, you can use it. But the key here is, the takeaway here is, now you have an option to key your mappings, right? So I have this mapping. Now I can map to this implementation. This mapping, I can map to this implementation. I'm going to call that as a local. I'm going to call this as a UTC. That's an example. And another example, you want to look at the cost for multiple different shipping provider. You can do, iShipping, go to FedEx shipping, iShipping, go to UPS shipping, iShipping, go to USPS shipping, and so on. So there is a lot of need for keyed singleton in any system to look at it, right? But now they have it in a .NET 8. Okay, that's again, this is nothing different. We're just going to inject class as a class. I will show you how we are using it. Okay, so with this, I'm going to run this. So all we have is the keyed, all we're going to see now, keyed injection, dependent injection using the keyed, and then the, that's the only new thing over here. Then we will come back and modify these to, so other thing that I want to show is the Redis key, right? So if you look at this implementation over here, this is not hard to do before. You just have to do it manually, but now they brought it part of these, the core. Okay, so you can do add cache output or Stack Exchange Redis cache, and then you give the Redis cache value over here, and then you can set instance name, so it prefixes that key, and then when you say add output cache, you should also say use output cache. Okay, use output cache. Then you can use it within this over here. Okay, when you look at the values, cache output, P2 expire from milliseconds 5. But this is not hard to do in the old releases, but it is now available part of the core framework. That's the only difference. But obviously most people would have already done that. How to handle these in earlier versions. Now. This also comes with some property. You can leave it as a default expire, or you can set some, use our predict expire in whatever time you want to set it. I set it 5 milliseconds. Start from seconds, 5 seconds. Okay, so let's run this demo and then modify a little bit more for the AOT and then the other stuff. So I'm going to make it to doesn't matter. So let's run interactive mode. Debug, start new. Debug. All right, let's cancel. Let's close this one. Debug. Start new instance. In browser. Right. So as I said, it's nothing new here. It's a very simple plain vanilla demo. We have that, and then we have look at the items. I believe this is where we have the caching thing here. All right. Here, I guess. Try it out. Look for item number 2, maybe. Okay, and then the get time, which is our time provider, which already is in the console app, and then it just returns whatever our implementation is, and then get time 2, similar way. I'll tell you why there is a true over here, and then it returns here. It returns some values over here. The problem, the difference between get time 1 and get time 2 is that get time 1 uses the interface implementation, right? So I'm going to stop this. If you look at it over here, we're saying it from keyed service. Okay, so if you do if you add a keyed service, and you have to refer that as a from keyed service, and then we say UTC, use that keyed service UTC. That's what it's going to inject. When you call the map cut, it's going to inject the UTC mapping of that. Okay, this class, my UTC time. Okay, but what is this one is, you can also map it in a different way. So if you look at this class, I can define a class, then I can say inject in a local. So see the difference? So this one is, you are constructing the map get as a constructor, but this one you take a class, but the class has the the parameter called from keyed services. Okay, and then it passing it in. And then it invokes that. And we have some 2 methods to return, some just for a demo, and returns those values. All right. Now what are you going to see? The AOT of it. Okay. So I'm going to comment all these things over here. And then I'm going to uncomment this stuff. Okay. If you run a AOT, you cannot run in a debug mode. It's not going to work, but it may bark at several errors. You can make this to uncommented, but still you won't be able to use it because an AOT is not widely supported. But do you have to use AOT? It depends. But it is not. Maybe 3-4 years from now, AOT may be much popular in a web service until we will see how the size and performance comes in. But right now, it's good to use the some minimal API if you run into. So I'm going to comment this because I don't need the Redis cache. Okay, so I comment that. And I'm not going to use anything over here, so I comment that. And then I don't know, I need this one, I comment that, but it doesn't matter to me. I will leave it because there's going to be no caching over there anyway. Okay, so Now we have this class. So how this knows, if you look at it over here, this is the create builder, right? But now they have a create slim builder, okay? And they also have something called create empty builder, okay? So what is the difference between create builder, create empty builder, and create slim builder, right? Create builder is the one that we've been using for a full application. Create slim filter is, it brings that AOT like a smaller package, faster runtime. And the empty builder, you want to simply return something. It's like a heartbeat, right? So you want to return a small code, that the smallest code possible to return a heartbeat, you can do that. Simply create an empty builder, and then, you run and then return something like a async write, and that's it. After run, like just 4 lines of code. Then you can use the empty builder. But the slim builder is what we're going to use for the AOT demo. So to do some JSON mapping, we need to have this. So if you look at that class implementation over here, so we need to have this, right? Because we're using the to-do class. The to-do class, we need to provide what is the app.json serializer context, which is coming from this context, and then we need to say all the types needs to be defined. If we have a different type, and we need to explain all the types that needs to be defined, so that it knows how to serialize that. Okay, that's the requirement. If you use the slim builder, and then you have object needs to be used. If the type is not a primitive, which is a string, number, data, boolean, and so on, then you need to provide that values. Hello, can you hear me?
Yeah, I was just about to ask you, there was a little silence just for 2-3 seconds, but wasn't sure if you're just switching screen.
No, I think my internet sometimes it does this. I don't know why. I apologize.
Oh, no
so you're
problem.
able to see my screen still?
Yes.
Okay.
Yep.
All right. Let's continue on. Sorry, guys. That's internet glitch. So I have the so we have this implementation. We're going to see how this is going to use, right? In order to do AOT, you need to have this functionality enabled, this project property enabled, right? So you say publish AOT true. That's all you need to know. There is other properties. I will walk you through how trying to compare the size of it, but all you need to know is publish AOT is equal to true. Now, once you set that, and you can build this library, Control C, and we're going to go back to the project. So we're going to go CD, net 8 min. Okay, we are in the project. Now we're going to compile the project. Before I compile and go further, I believe I didn't explain you what is AOT. I have some tech here. So it's a faster startup time, smaller file size, smaller memory frame. Okay, so I think to some extent it only goes up to 15 megabytes. Okay. The DA change, we talked about it. Redis caching, we talked about it. Background worker, I'll come back to the demo later. But let's now do an AOT demo here. So if I look at it, so I'm going to compile it. For the compilation, I need to use a .NET publish because you need to pass it in the operating system target we're doing it, .NET publish. And I'm going to say bin ix64 and release mode. Okay, so this can build that. We'll take 30 seconds. Any question so far?
Yes, so I see that there's a lot of performance enhancements. So one question is, if I had a .NET 7 application and I just upgraded to .NET 8 with no code changes, do you think I'd see performance enhancements?
Yes, yes. That's a key marketing value they've been talking on every tag. Yes, just by switching to .NET 8, you get those performance that we talked about it. For example, header parsing, how they handle the thread pools and how they handle the wait times and everything. You get that out of the box.
Oh,
You don't have
great.
to change any code.
Okay, great. And then I'm not 100% sure on this, so correct me if I'm wrong. Is it, so you have to have Visual Studio 2022 for really .NET 6, 7, 8, is that correct?
You can, if you install, if you need a Visual Studio, you need to have a Visual Studio 2022 17.8. If you use a VS Code and then you install the .NET 8 and corresponding add-ins, and keep going. But you can run the 6, 7, 8 side by side. So if you have a project side by side, you can use that.
And then, sorry, just one more question. I
Yeah,
know a lot of old code, so like I had the Visual Studio 2019 running and all. Is there a direct path to upgrade from like .NET 5 to .NET 8, or I'd have to?
There is upgrade Visual Studio. If you are in a .NET 5, you may be able to, lucky enough to convert to a .NET 8. But if you're in a .NET framework, it's not clean. You may have to plan, either you run side by side or you start over. That's a strategy you need to plan for it. We have application in 4.8, and I thought that upgrade wizard will help me, but that upgrade wizard is pretty overhead in my experience. Okay, perception changes, and the application to application it's different. The application that we use, it's not a very easy to use the upgrade wizard until we manually convert a few things, not few things, a lot of everything. But if you're already running a .NET 5, those wizards can definitely help you.
Right, great, thanks.
Okay, so if you look at it over here, right? So this is all coming down to very simple. It creates a one exe, which is the 14 meg, I guess, right? And then all the files. It's built in all the runtime. Everything is over there. So now we're going to run this net 8 min api.exe, and that listening to the HTTP port 500, and we're going to open the this guy Postman. When it loads, I'll bring it over here. Everything freezes today, I don't know why. Come on. Slowly. Okay, so in the Postman, we can send to the request 5,000 to-dos. You see the data. Again, you want to look at the to-dos class 1. You got the data, and to-dos class time, my time, and my time. Right? What is it? Okay, my time 2. Sent. We got it. Right? It's all works, but it's only the one small file, one package is created and then using it. Okay, that's the AOT. It creates the exe. You can ignore the PDB file, and then it creates that in proc.tll, ASP.NET in proc.tll, and there comes from. That's all it is. But if we can package this as a single exe. Let's see how that's going to look at it. So if I'm going to go here and then I turn off this. Right? And then I turn on this, you trim it, you do all those things. Okay. It can create the same package. So I'm going to enter this one over here. Okay. Now if I do publish this on the same switch. Okay, so let's publish it again. But this time we are not publishing using the AOT, but we use the other switches, like, give me a single file exe, but you trim it everything that you want. If you don't trim it, the file will be even more. So you can play with the different settings. What is the size when you do a single file? What is the size with or without trimmed, right? All the trimming is going to see, now we have the Redis reference and everything. It's going to remove all those things. So if I go back to this folder here now, okay, so if you look at the DL, so remember last time it was 14 meg, right? Now if you look at it, it's like a 20 meg. That with the option trim is equal to true. If you don't trim it, it will go higher. And I don't want to waste time. We are running out of time here, but you understand the concept. For this demo, I'm going to comment this. Or I can leave it, doesn't matter, but let's run the AOT of your remaining demos in the AOT. Or maybe we don't even need this. Let's run it. AOT would be. All right, so we're going to run the remaining demo of the AOT. So what next we're going to see is, so if you look at this code, we saw the key dependency injection. We saw those, how to run the AOT, the Slim Builder. So next one, what you're going to see here is hosted service, okay? For the hosted service demo, I'm going to remove this code, comment this code here. And then I'm going to uncomment this code. You can even run, I think, and I was testing using the AOT code, but just in case I'm going to comment and uncomment this normal code. And I will also comment this stuff over here. Right, go back to the program. So this is, we are loading it. And then what we're going to do now, we're going to see the background services, right? So the number one thing that I'm going to show you here is the add hosted service and then a demo background service. If we go back to my definition over here, this is, this is mainly useful, you're running an app, but you need to monitor your own way of something changing, or, on the startup, you want to download something, or you want to do something as a bootstrap task. And this is the right way to do part of the ASP.NET host process, right? So this is the background worker. This was there before, okay? But, you can override this, you run this code, hosted service, and then do it. That's all you need to do. It's going to start running, okay? Now if I come build this object, build it. And we see where exactly this end up. Okay, so the path is cd cd. This is going to be bin debug. Okay. So we build that way. Okay. cd. All right. Bin cd debug. cd net project. Okay, so we have it over here, and then we're going to run the net 8 min API.exe, right? So let's type the net 8 min API.exe. So if you look at it, you see that it's first calling these background worker, right? Execute async, and then every minute or whatever the time we set it's going to call. So the key here is your background worker is being called. But if you don't have this, async way of doing it, it should wait here. Okay, so they support this syntax now. Okay, otherwise it should wait. And it may take, like, if it comes quickly, that's okay. But oftentimes you don't have to wait, right? You can do other tasks instead of waiting. There is a timeout, 20 seconds or 30 seconds, I forgot the value, but you don't have to wait for it. So now you can launch and then keep going on it. And this is like a constant loop. So it's going to go in a while loop and then write this every 5 seconds, which is the 5,000 milliseconds. Okay. So I'm going to exit this for now. Now I'm going to comment that line. Then we're going to see the, this is the new one, hosted service. So you can do that add hosted service, the background worker, look at the inheriting class, which is the background service. But in this case, we're going to do the hosted service, right? Hosted service gives you 2 options, start async and stop async. You can start and you can stop. So if this takes a long time, even though it says to start async, it's going to wait for it, okay? And if it takes a long time, it's going to wait for it. But instead of waiting, you want to do it in a non-wait mode, you have an option to say here, service start concurrently true. Like, it still starts asynchronously, but if you have multiple services, they are not going to wait to one another. But the default behavior is to run one after the other. It was sequential, right? So in this case, we only have the one service. If we have more than one service, it runs the service 1, service 2, service 3, service 4, and so on. But now you can do all the stop concurrently or start concurrently, okay? This is mainly helpful if you have multiple services that are trying to fetch a lot of information while the service is starting or stopping. And this is a very helpful feature, okay? So you can do that. If you compile it, this one now, we are in the debug mode, so we are already in the debug mode. If you're on it, so we compile it. Okay, demo hosted service, start async. And then if you do a control C, we are stopping it technically, stop async. But if you have more than one service, it call that way. That you can pass it in using the configuration option. So now the next one is, this is new, is it gives you a lot more events than just to start and stop. So if you look at this code over here, this is the host lifecycle service. So this one is the background service. This one is the hosted service. This one is the lifecycle hosted service, which contains a lot more events. Start async, stop async, started async, starting async, right? So you have the starting, start, started, okay? Stopping, stop, stopped, okay? So you have three events per event, right? So if you run this code over here, you just build it, and then go back and run this code over here. You can see already, starting async, start async. Starting is the first one, then the start, and then the started will fire in after the, it started already. If you're going to enter this, it's going to say stopping, stop, and stop. Okay, so it gives you one more way of handling those data based on your application requirement. All right, now let's bring it over here. What is the next we want to talk? That, we gone through that, we gone through that, AOT, we gone through it. So request delegate generator. So what is a request delegate generator? This is by default applied on AOT is equal to true, right? Publish AOT is equal to true. What it does is, again, it creates, instead of the get map, right? So if you take a min API, it has the map get, map post, map put, map delete, and so on, right? So those things are reflection to map after the code compiled. But these request delegate generates the delegates at the time of compilation. Okay, so it saves the reflection time. So reflection is always expensive. So it is, instead of doing the reflection at runtime, it's now it generates the code which is compiled and then it transformed into the bytecode. Okay, this is by default enabled for the AOT publish mode true. If you want to ask manually, you can go on to set the enable request delegate generator true. Okay, but AOT mode it's always. But non-AOT mode, you can set that option by saying the enable request delegate generator true on the project property, then it will set that. So that's what we have it over here, right? Enable. Similarly, JSON reflection, you can make it true or false. That's the behavior we talked about. Instead of serialize and deserialize, it's always happened through the reflection. But if you want to change the behavior, you can do that project properties. All right, let's go to the next tech. what we have here. Mavi, right? So Mavi, they have again, startup performance by using these AOTs. iOS is based on the size performance, and Android startup and Native AOT now they support on the iOS for the faster startup because I do mobile development. We use the Java and the Swift. We are not using the Mavi yet because some of the things that we're looking at is not available in Mavi, mainly the interior integration. But the Mavi, there's a lot more functionalities coming. Memory leaks, they fixed it, and then the Android improvements in Java Intrap, how you do the text and label mapping, right? So you go from Java Mavi mapping to the Java mapping, how they've been asking before is more memory intensive, and now they optimized that. So even any application you take it, they have lots of text boxes and labels, right? So if you have application label centric, that means that you have creates a lot of labels, and you're gonna have performance problem that's being addressed in the Mavi. And then you have .NET Trace, .NET garbage collector dump, which is already exist, but now what they have is a .NET DS router, which you can, Android, EMU, iOS, SIM. What did that does is it let you communicate the remote object .NET is running and then collect those traces. So you can now, without having the .NET installed, you can create all those things as if the .NET is running locally. Okay, that's the main point of DS router. So it's just routing to the remote .NET as if the .NET runs locally. So you have the Mavi code that runs on the device as if the .NET running on the device. You can remote that to a remote .NET. Okay, and the last one, I think that's the last one. Yeah, I want to talk about the Semantic Kernel, which is not a .NET feature. They've been releasing it. They released recently the beta, which I'm going to put a pretty big topic for next month. Dan is going to do one in January first week. Wait for the announcement, and after that, maybe end of January or beginning February, I will present this semantic kernel in a real world application. Anything that I present, it's come from my work, whatever we experiment and we try to bring it to our community talk. The semantic kernel is also we're working on right now. We'll try to demo on a nice real world applications, how it can be used by using the Azure OpenAI and so on. This is some of the scenario that we can demo. But again, this is not part of the .NET 8. They just released in the release candidate. The other thing that I forgot to note on here is the .NET Aspire, which is the opinionated framework that Microsoft released it. You can download. The advantage of it. If you don't know how to deploy, what to select, then .NET Aspire is the right thing to do. If you download the add-ons, which is still in a beta or preview, you can download it and then you can play with it. But again, those are big topics. That's not part of this particular talk, so I didn't bring it in. Now, the next topic we're going to, next month, we will have 2 topics. One from the Dan, he's going to talk about the DNSs, Route 53 and the Azure DNS, and then we'll try to accommodate semantic kernel end of next month. Where is next? And then these are reference that I gone to. There's a lot of reference, a lot of YouTube videos. And if you go look for the .NET channel, and you will find a lot more videos. And all my talk coming from the .NET channel videos that came from the last month .NET release conference. So I put these things. This presentation will be available. I put them in the comment section. And the recording will also be available.